joining in and welcome to your learning journey on Agentic AI. Now, you can see that like in the last, I would say few months, especially in this recent days, there's a crazy development that's happening in this AI space and specifically in the Agentic AI. Now, the agenda of this session is to get you up to speed about what exactly is this Agentic AI and how easy it is to get started so that you'll have a clear path and understanding about what exactly is this agentic AI and how everything would work. So I just want to know from you guys, okay? So what do you know about agentic AI? Let me know in the chat window about what do you know or your current understanding about agentic AI and what's your overall thought process behind this? Okay, I can see responses already. I can see that some of you are saying that it's a system that can answer the questions, take the decision. And Rachita says that that's something, the agentic AI is a system which would help us to, okay, perform a specific task. Perfect. So I can see that. Okay. Uh, So Shiva Yogi says LLM plus tool plus memory is called as an agentic AI. That's also a very good one or a good way to mention it. And for the folks who have joined in from our social media channel, just post your responses in the chat window. I'm looking at the chat window as well. Okay. Lakshman says, yes, it's basically LLM plus having the capability to understand and do something. Okay. Uh, all right. Okay, Rahul says I'm non-technical. It's fine. So today's session, it's not a course or anything. I just want to give you an idea about what is agentic AI and how simple it is. It's more about, I'm going to say it's a mix of both practical and theoretical, but the intention is I want each and every one of you of this session to understand what is agentic AI. And I want to let you know that it's not so special, but it's simple as well. So I'll give you some tips and tricks that would help you to get started and I'll write the code in front of you which is easier for you to understand, which will give you a way to proceed ahead in this agentic AI journey. Okay, so let's get started, guys. So one answer that I really liked the most, I would say, is agentic AI is basically the large language models plus tools plus memory. So let's extend that answer and let me extend that answer and let me just help you to understand what exactly is this agentic AI in a very simple sense. Okay, so let's take a look at it. See, when we consider the agentic AI or anything, okay, let's start with the generative AI model. So we'll start from the generative AI model and we'll proceed ahead from there, guys. Okay. Yes, I also see a few other responses as well. LLM plus toolkit, GPT with access to tools. So most of you are saying that it's basically the LLM plus tool. That's a perfect one. Okay. And now I can see a few more responses as well where it can take action, make decision, act on behalf of us. Perfect, guys. Now let's start from scratch. Okay. Let's start from the understanding that we have got. Now, here for example and for the easier understanding purpose, I'll take the example of ChatGPT. So if you consider the ChatGPT, how does it work? As a end user, okay, this is you, the user. What you will do is you will provide a prompt to a generative AI model. Okay. I'm going to say Gen AI model. We also use the word called LLM, that is large language model. You will provide an input to this generative AI model, which is what we call it as the prompt. And once we send this prompt to this LLM, what this would generate is basically the response. So this will generate a response. So this is what happens in the scenario of the LLM. Now, if you have used the LLM in the past, or if you have used the core idea or the core large language model, so one of the key things that it has got us So one of the key properties, okay, I'm going to talk about the properties. So properties of a large language model or a generative AI model that we have got. So one of the important properties is it is stateless. Okay, it is stateless. And along with that, by default, or when we say any generative AI model, it does not have conversation memory. And another core important element that you need to know is when we talk about this generative AI model or the core generative AI model, it does not have, I'm going to say, access to tools. Okay. Now, this is a core property of any LLM or a generative AI model. Now, you might think that, hey, I've been using ChatGPT. Now, the ChatGPT actually do not have this property. It's an opposite of what you would see in the ChatGPT. Like, for example, if I just go to the ChatGPT in front of you, so this is an important clarification that I want to give. That will be a foundation for agentic AI. Now, when you consider the example such as the ChatGPT like an application, first of all, when you say ChatGPT, this is not a generative AI model. So this is basically an application that is created by OpenAI. Okay, ChatGPT is an application, and over here the model that you see GPT-4o3, these are all individually, these are all the Gen AI model. So the OpenAI team, what they have done is they have built the capability on top of this generative AI model. So that is one of the reason that when you ask something for ChatGPT, like suppose if I ask as tell me about agentic AI by referring to latest industry reports. Now, when I mention this prompt right now to this ChatGPT application, it's going to perform the web. It's going to perform the web search. It will fetch the data from the web and it's able to generate the response. Okay. So this is a property that you would see in the ChatGPT application. But when you are working as a developer, or when you think about developing any application using the model such as 4003 or Grok or any model, okay, in such scenario, some of the important properties that you need to remember here is it's stateless. Now, when I say stateless, it doesn't remember the previous conversation that you have had. It does not have the conversation memory and it does not have the access to the tools by default. So it can actually get a prompt from the user and generate the response for us. And this response will be basis or it will be based on the training data that I have had. So that is the core idea about the large language models. It will be able to generate the response based on the training data. If the data is not part of my training data, it would go ahead and tell me that, okay, I don't know what is it that you're saying. Can you refine me the question again? Or uh, can you tell me other question? So that's the kind of response that you would get from a large language model. Now to illustrate this property, let me just take you through a code. So the intention of this idea or intention of showing this demo is to show you about the reality of this LLM application and why this agentic AI based application is actually important these days. Okay, why learning these is important and how you can get started. So let's consider an example. So I'm just going ahead and setting up my environment. It's just for my local execution. And let me just go over here in a particular folder. Now, what I'm doing right now is, okay, I'll give you a very simple example, okay? Let's say, okay, so I'll give you a very simple example. So here, I'm interacting with the OpenAI model in this particular code that you see right now. I'm actually going to interact with this OpenAI model, and one specific version of the model that I'm choosing right now is GPT 4.1 Nano. So this is a specific version of the model that I'm going to use right now. Okay. Now I'm going to ask a question. Okay, that question that I'm going to be asking is, okay, let's take up any latest sports news. Let's say uh, latest F1 news. So if you consider the latest F1 news or F1's news, let's say F1 race. Okay, there was a race that has happened. Let's say the winner was Lando Norris. Okay, now let's assume that, like, if I ask this question, okay, who won F1 race on July 6, 2025? If I ask the question to my chat GPT, the chat GPT will be answering me because, as I mentioned already, this is an application. It has got the various capabilities that has been built on top of my model that I have, let's say the GPT 4.0, and it's able to generate me a response that says that Lando Norris was a winner. That's great. Now, let me ask the same question in a programmatic manner, not through ChatGPT, but for the model itself. Okay, this is a very important thing that you need to remember and understand. I'm going to ask the same question over here. I'll ask a question that says that who won the F1 race on July 6, 2025? Okay, don't worry about the code. So I'm just saying it, I've initialized the model and I'm trying to generate the response for this question, who won the F1 race? That's what I'm trying to do right now. Okay, so let me just go ahead and execute this code and let's see what would be the response. So here, the Python file is system human. Okay, so I'm gonna execute this file that I have. Launching demo. Okay, in a different folder. So now, if I ask the same question programmatically, okay, can you look at the response? Let me clear everything and let me call it again. You can observe it in a much easier manner. Now, I'll zoom a bit as well. Just observe the response right now. It says that, I'm sorry, but I don't have the information on events that occurred after October 2023, including the F1 race that has happened on July 6, 2025. So this is a proof that, okay, when you're working with an LLM model as a core principle, okay, as a core capability, or some of the key things that you need to remember here is it is stateless, and that means the answers are based on the training data only. Okay, the response from the LLM is based on the training data only. There is no response, like it cannot, since it does not have the access to any tools, it does not have the capability to perform the web search and get the latest news from the website, sports website, and generate me the answer. It does not have the inherent capability or built-in capability inside it. So if it is not part of its training data, it will not be able to answer. Like if I ask a simple question, maybe like a simple question is, what is the capital of India? Or, okay, capital of India. Okay, if I ask this question, so since it's a simple question, Since it's part of the training data, it's able to generate the response. Says capital of India is New Delhi. So this is a clear example that when we consider the LLM, the response from the LLM is on the basis of the data it has been trained upon. So that's a key thing that you need to remember. Now, because of this property, yes, we have some other architectures that has been introduced. That means since we do not have the data, let's say in this given example itself, since my trained data do not have after 2023, so one way the researchers can come up, or the solution that was proposed was, okay, let us feed the external data, whatever the external data that we have, we will feed that external data in the format of a vector database. And during the runtime, we are going to fetch that information. During that runtime, whenever the user sends in the prompt, okay, I'm going to refer to my vector database and get the details. I will combine them together, my prompt and my context. And then once I combine this prompt and context, my LLM will go ahead and generate the response. My LLM will go ahead and generate the response. And this architecture is called as RAG architecture. So what is RAG? R means retrieval. That means I'm going to retrieve the data from my vector database. A means augmentation. So for the user query, I'm going to augment the retrieved data. That means I'm going to add those information together. And then I'll use my LLM to generation, like to generate the output. G means generation. So retrieval, augmentation, generation. So that is the overall full form of RAG architecture. So that means we can have a static knowledge base. Okay, I'm going to call it as static knowledge base. And using this static knowledge base, I can get the context from my vector database and generate the response during the runtime. So this is one of the most commonly used architecture in the industry right now, because in most of the industry application that we will be working, let's say whenever whenever I want to answer something, I just want to refer to my static knowledge base and I just want to generate the response. I'll give you a very simple example. Let's say you want to, let's say you're building an LLM for your own company, let's say for the company that you're working with, and you want to understand, you want to build a Q&A system. Okay, the application is Q&A system. Now for this Q&A system, what is it that you're interested is whenever someone asks about your policy, which could be your HR policy, you should be able to answer it in an efficient manner by referring to your company policy document. So in this scenario, what you would do is, first thing is you will perform the indexing. So when I say indexing, you are going to get your source data. In this scenario, maybe you have all the company policy documents is present in your SharePoint. So you will extract all the documents which are present in your SharePoint and you are going to store it inside the vector database. So you will perform some technical aspects around it. I'm just making it very simple. Generally, when we are loading it, we perform chunking, we perform embedding. For simplicity, just remember that you'll perform the indexing where you will send the data from your SharePoint to your vector database. Now, once you save your data inside this vector database, now once you have built this generative AI based application, maybe you're also making use of the generative AI model. In such scenario, let's assume that as an end user, you will ask a question. The user will say that what is the maximum reimbursable amount for my broadband bill. So let's assume that your company provides the reimbursement of your broadband bill, and the user is trying to understand, okay, what is the maximum reimbursable amount? Now, this information will be the query or a prompt. Now, you know that any company will have the document and they'll have this documentation present. So here, what we will do is to answer this question, we are going to retrieve that part of the text which is related to this broadband bill. I will get that information from my vector database. Now, in this vector database, I'll have the information that says that maximum reimbursable amount is, I'll say max amount is equal to 2000. Let's assume that this is the information that is present in the vector DB. So for this question, I'm going to include this context and I'll provide both of this information to my LLM. My LLM will look into the question, will look into the context, and will give me a response that says that, okay, this is a particular response for this given question. And this architecture is called as the vector database. Okay. Now, here, the reason this vector database has been chosen is, so to give you some technical insight, whenever we are working with the text, so I want to get the related text. So to be able to look into the relatability in an efficient manner, we convert our text into a vector format and we store it. We store that vector related details in the format of embeddings in the vector database. And this vector database has got special capabilities that is built inside it, which will help us to fetch the related content from the text in an efficient manner. So that's the reason that we use this vector database. And by combining this, we are able to generate the response. And this is the overall idea about the RAG architecture. Okay, where you will provide the where you will store your existing data in the vector database by converting into the vectors. Then whenever you're sending the new query and the related data will be fetched from the vector database and it will be added in the context and the response will be generated. So that's a core idea about the RAG architecture. Now, this RAG architecture has got a lot of advantage, but as you can clearly see, it's a static database. It does not have the capability to interact with the uh, other tools that we have got. Okay, so from all these examples, so one thing is clear, the LLM does not have the access to the tools. And another key thing that I've mentioned is stateless. So what is stateless? So when you're having a conversation, when you're sending the data to the LLM, in such scenario, it doesn't remember about what has happened in the past. To illustrate this, I've got a very simple example. So just take a look into this example. Over here, okay, I've got two sentences over here. The first sentence says that Ramesh in our class has won the cricket match yesterday. And I'm asking a second question that says that who won the cricket match which Ramesh was playing yesterday? Okay. So if you take a look into these two sentences, you know that the answer to the second sentence is actually lies in the first sentence. Like as a human, I can clearly say that for the answer to the second question is Ramesh, because that's what I'm clearly conveying in my first sentence. Now, what I'm doing right now here is for the demonstration purpose, I'm sending both of these sentences. Okay. I'm sending both of these sentences to the same GPT model and I'm trying to generate the response for both the questions. So this is what I'm doing right now. I'm just going ahead and generating the response for these two questions. So let's take a look at it. So now I can see a response. The first response is, it sounds like Ramesh in your class has won the cricket match yesterday. Congratulations to him. If you want to share more details about match or discuss anything, feel free to ask. That means for the response to the first question or first information, It is celebrating with me. Now, take a look into the second response, and this is a very interesting one. Here it says that, I'm sorry, but I don't have the access to real time or recent sports update. Even though we know that the first line actually has the answer to it, it clearly says that it doesn't have the access to the real time data. I recommend checking latest scores on the sports news website. So, what it means is, by default, when I'm working with the large language models, it does not have memory. Okay. By default, it does not have memory. It is stateless. So it doesn't remember about what has happened in the past. It's very dumb. So that's the key property that we would see right here. And another thing is it does not have the conversation memory as well. Like when I ask the same question, it will just go ahead and generate me the same response. Or it might call the LLM again, even though I might have asked earlier. It does not have the conversation memory. So these are the core properties that we would be having when we are working with the large language models. But in the industry, I don't want to just generate the output. I want a system which is intelligent enough to fulfill my given task. I don't care about how many steps it will do. I'm just interested in performing the task, or I'm just interested in looking at the outcome because I'm interested in the outcome. I'm not interested in I'm not interested in like which way or which model it is being used. So building the system which has got the capability to look into the user input and take the necessary steps to fulfill the task automatically. That kind of system is called as the agentic AI system. Okay. So that is what we have got. Let's ask the same question. So if I just want to give you the definition of agentic AI system, okay, I can say that here, agentic AI system, I can say that it's an advanced form of AI. And it's something which acts with purpose, like a human agent. So you can think of the agentic AI like a chat GPT, guys, because they have evolved this application like crazy. And you can think of this similar to the chat GPT. Like when you ask a question to the chat GPT about anything latest, it will refer to something, it will generate the response. And if you ask the chat GPT to generate me a PDF, it will do some stuff and it will generate the PDF. So that's what an agentic AI system is all about. It's a system which is an advanced one where it will act automatically with purpose. Okay, so it acts autonomously with purpose, like a human agent. See, when we are dealing with human, how do we do? So if we have a colleague or a teammate, or even the way it would work is, will that boss will say that, okay, this is the task that I want you to perform. So we will go ahead and perform the set of activities to fulfill the task. And similarly, if I want my computer system to do it, that's what the agentic AI system is all about. So this is a special kind of system where it doesn't just respond to the prompt. It will plan, it will decide. If required, it can also collaborate with multiple other agents. It will take the initiative such that at the end, it will be able to accomplish the goal. So that is what an agentic AI system is all about. So when we talk about this agentic AI system, the key properties that you'll be able to see is, first of all, it can work autonomously. It works on a goal-oriented fashion. Excuse me. It has got the conversation memory. It knows about, let's say if there are four agents that are working, just like I can have a team of four people working together, I can have a multi-agent system or multi-agent setup where I can have multiple agents working together to perform a task. And this can have the access to the tools, like it can perform the search, it can retrieve the data from other website, can retrieve the data from my database, it can retrieve the data from my knowledge base, like a vector database. It has got the capabilities, and it will go ahead and fulfill the task and coordinate with other agents or human. These are the core characteristics that we'll be able to see when we are working with an agentic AI system. Like, to give you some examples, like to give you the overall components of this, the agentic AI. I think some of you have already answered at the beginning itself. An agentic AI will consist of an LLM. In core, it will have an LLM. It will have a memory store. Okay. It will have a tool integration layer, and it can have the executor. We'll also have the observer and planner depending on the complexity of the architecture. So that is the overall idea about what exactly is this agentic AI. So it will go ahead and perform the task autonomously to fulfill my goal. So what it means is, if I want to build an agentic AI system which has got the capability of doing all these things, then I would expect that whatever the tools that I want to use to build it, that tool should be able to work with LLM, should have the access to memory store, should support the tool integration, should support the executor, observation, planning. It should support everything. If I have the tools which supports everything, then only I'll be able to build the overall agentic AI architecture and develop the full application. So that means we want the library or a framework which supports all these. Now, coming to building the agentic AI and building these AI agents, we have various frameworks, and these are some of the most commonly used one. The first one is LangChain and LangGraph. LangChain is an open source library, and LangGraph is what we use it for multi-actor, like in agentic AI setup. That's what we use it. So LangChain with LangGraph is one framework that we use. AutoGen, Crew AI. So we have the Bedrock agent, Google Vertex, Microsoft Autodev. So these are all some of the examples of agentic AI framework. So overall, I can say that these agentic AI system is like an assistant which has got the access to the tools. It can understand the task, make use of the various tools, and coordinate together such that the end goal can be achieved. And that's the overall idea about this agentic AI system. Okay. Now that you have understood about this, I'll give you a very simple demo as how it actually works. Okay. So for the demonstration purpose, I'll go ahead and make use of this LangChain and LangGraph. Now, as I mentioned, we have other frameworks as well, but for the demonstration purpose, this is what I would be using for now. Okay, you don't have to be master at it to look into the code. I'll explain what is happening over there, guys. Okay, just don't worry. Uh, build the intuition. That is the overall intention over here. So let's take a look into this. A very simple example, team. Okay, so let's build a very simple agent. Okay. All right. So I can see a few more questions. Okay. Now, before I go over there, guys, okay, before I take you through the same, are you able to follow along with me so far? So if you're able to follow along with me, just type in as all good in the chat window. Or if you've got any question, let me know. I'll give you a minute. Okay. I can see few learners have asked specific question. I'm just answering. But before that, if anyone have you have got any other questions, let me know. Okay. Okay, team. So thank you so much for your response, guys. And I can see most of you have confirmed. Perfect. Okay. Uh, Perfect. So then when it comes to production deployment, can you talk us through some sample architecture? Definitely. I can definitely show those as well. Okay. I'm just skipping the query and questions which are not related to our current discussion. And there is few questions about N8, N8, and I think we will talk about it as we progress. Okay, folks. So perfect. So let's just build a very simple agent, guys. Okay, now this agent that I'm going to be building right now is will have uh, the model. So in this scenario, I'm going to make use of the OpenAI model that I have, and I'll build an agent which has the capability to get the data from my Wikipedia. And once it gets the data from the Wikipedia, I should be able to use the data from the Wikipedia and generate me a response. Okay, that is the overall intention of this code that I'll be showing you. And in order for me to implement this, I'll just go ahead and prepare the files right now for me. So I'm gonna say main.py. So over here, I'm gonna add few things which would help me to work with it in an efficient manner. Okay, these are a few things that I will be loading. So I'm importing my chat OpenAI for working with the same. And here in this case, I'm also making use of LangGraph. And to be able to work with Wikipedia, I'll make use of the Wikipedia API wrapper as well. So LangChain utilities, I'll be importing Wikipedia API wrapper. And few other things that I'll be loading is from langchain.tools. .tools, I'll be importing tool. Okay. I've imported the state graph, start and end, which is essential for me. And from langchain.chain, I'll be importing my LLM chain. And I'll also load the prompt template. .prompts, I'll be importing my prompt template. And let's also create few things. Okay, from langchain underscore core dot runnables, I'll be importing runnable lambda. Okay, so I'm just doing some imports which are essential for us. So don't worry too much about the code. The intention of this session is to not confuse you with the code. Let me do one thing. Let me just mention the entire code and I'll explain what is happening. Okay. So first thing is I'm going to create the object for Wikipedia API wrapper. Then I'll define the prompt. Okay. And let me define my model here in this case. The model that I'll be using is this. Chat OpenAI, and I'll call it as LLM. Okay, this is the model that I'll be using. Then I can go ahead and mention as LLM chain using my LLM and the prompt that I have. Then once this is done, I'll go ahead and create the graph. Maybe I'll just go ahead, yeah. Let me just copy paste the code that I have with me in the other system. So over here, I've just added the code that I have and I'll explain what is happening. Let me just create a plot over here. So to download the prompt, let me just generate it right away. So this will just go ahead and download as well. Now, let's do one thing. Let's run it and then I'll help you understand what is it that it's going to be happening. Okay. So now I'm going to say cd stop. I think I've exited the app and I'm going to say line chain. No, that's the folder that I'm at. Just bear with me, folks, so that we can look into the output right away. Let's me just do a simple run. Wikipedia, okay. Okay, so let's take a look at this, guys. So here, when I run this main.py, it says ask a question. I'm going to ask a question as, what is agentic AI? This is a question that I would ask. And here we are getting some error, key error question, state question. Let's fix that. So we are creating a state agent. Okay, we are adding these scenarios. State question. Okay. Now class agent state. So let me do one thing. I'm just fixing few errors. Okay, let me see. Okay, so I think let me do one thing, guys. Instead of me trying to decode it, let me just explain. Let me just take a look into the very simple example and show it to you, and then we can look into this demo with multiple agents in the next scenario. Okay, my apologies for that. I should have much prepared better way. So for this demonstration purpose, I'll just take you through a very simple example, guys. Okay, the example that I'm going to take you through is this. Here, see the core challenges that we have seen is whenever we are dealing with the LLM, it does not have a conversation memory, it does not have the access to the tools. Now, for the simple demonstration purpose, let me just show you as how we can deal with the scenario where we have the where we have the memory present. Okay, where we have the conversation memory that is present with us. To illustrate this, just take a look into this code that I have got. Okay, so over here, I've created some state graph. I've created the graph over here. If I want to show you a very simple graph, this is a simple graph which consists of a single node. We have a start point, we have a node called chatbot, and we have an end. Now here, the example contains an illustration which says that I have first information that says as hello, my name is Nachiket. And in the second message, I'm asking as what is my name? See, in the previous scenario, when we were mentioning these questions or when we were mentioning these kind of input, our model was unable to remember our conversation memory. Now here, with the help of the line chain and line graph, we have implemented the state, which has got the node and the required configuration. And when I run this script for the second question, that is, what is my name? It will be able to generate the response to me that says that, okay, your name is Nachiket. Okay, let's validate this. I think if we can validate this, that will be I'll say a goal achieved for us. Okay, so if I execute this, so observe right here. The first message was, hello, my name is Nachiket. And Agentic AI mentioned that, hello, Nachiket, it's great to meet you. How can I assist you today? Now, there was a second question from my side. The second question was, okay, the second question that I had mentioned was, what is my name? Okay, so as you can see the highlighted content, it says, what is my name? Now, when I'm sending this information, it is able to have my messages over here on top, and this messages contains my previous input and the previous response. That means we have the conversation memory enabled for me. Now, as a result of this, we have the output from the LLM. Let's take a look into the output from the LLM. So human message, let's see we have any. Yeah, we have the response from AI. It says your name is Nachiket. So this is a clear demonstration that by making use of this line chain and line graph, we are able to implement the conversation memory. We are able to implement the conversation memory, which will help us to ensure that we are able to build an application which can work like ChatGPT. So along with that, this line graph, using this line graph, we can have the capability to interact with the tools. We can have the capability to include the conversation memory. We can have all sort of things for this agentic AI system as well. So that's the idea about the agentic AI. Now, how can we deploy this? Now, or how this system or how this kind of system can be deployed? So for now, I'm going to give you an idea about how you can build a rack-based architecture, and you can actually extend this same principle for your agentic AI system as well. since I have the architecture diagram ready for this rack-based architecture, I'll just take you through that right away. Let's assume that you're building a system which looks like an architecture that look like this. Okay, just take a look into this architecture. This is a very simple rack-based architecture, and you can actually extend the similar architecture for anything as well. Like for your learning reference purpose, think of it in this way. Whenever you are building a system, which is a chatbot based on RAG architecture, so the first thing that we will implement is the cache memory. So the first thing that we will implement is a cache memory, where using this cache memory, it can be the Redis or any such database that we'll be using it for storing the cache data. And we generally mention the time to live. So whenever we receive any input, we're gonna store it in our cache database. And when the same input is received from the other user or similar users, if it is part of my cache store, then it will be able to generate the response directly from the cache. Okay, that is the first thing that we will have. We are going to implement the cache memory over here with the help of the fast accessible, let's say the cache database. Now, if it is hit is nothing but I'm able to get the data. Then in such scenario, I would go ahead and generate the response from it. If it is a hit, using the data, I'll generate the response using my cache store that I have used. Okay. If it is not available, okay, if that is not available, then obviously it's a scenario where we do not have the previous data that was available for us. So it will make a fresh call to my LLM. And while making a fresh call in this example, assuming, so this is a demonstration of RAG. So I will refer to my vector database. Like for example, it can be Redis database or it can be PostGRES, vector database, Chroma database. It can be anything, VV8. It can be anything. Just for simplicity, I've just mentioned as Redis database. It will fetch the relevant context from the Redis database and augment it to build the prompt. And this combined prompt will be sent to my LLM, which is basically my large language model, to generate the response. And finally, on top of that, we'll implement the post processing, which involves implementation of guardrail, ensuring that the output is in right format, and so on. And on top of that, in this pre-post processing, we're going to have the observability where we're going to capture the metrics, and in all these scenarios, some of the important metrics that we capture are latency, the time it took to fetch the data from a vector database, the time it took for the LLM to generate the response. So those are the two important latencies that we'll be looking at. And apart from that, the input that has been received, the output that has been received, we'll be going ahead and create the audit logs for the tracking purpose. We're gonna look into the other information such as applying the rate limits to ensure that like at a given point of time, only specific number of requests can be received from an end user. So all those aspects that we would consider it in the architecture design, and we will monitor those metrics. Like here in this example, I mentioned as Prometheus. So we'll push those metrics into the Prometheus, which can be which can be scraped by my Prometheus server that's running, so that we can have a reports that gets generated in Grafana. So that's how you can implement the production-based architecture for a generative AI-based system. Okay, this was a very high-level overview about what is agentic AI and what are the best practices that we generally follow when we are implementing such solution, guys. Okay, now I'll take a pause here. So any questions, if anyone of you have got, do let me know. Okay, so I'm just sharing you the link over here in the chat window, so that just take a look at it as a reference so that you'll have a idea as how it works. Okay, so I think this diagram tells everything. And there are few there's one important question from Chris, and the question here is, what is cache? Uh, Especially when we are working, and what does cache memory or cache database will do? So let me answer that. So first of all, what exactly is a cache? A cache is a fast access storage layer. It's a fast access storage layer. It will hold the data in a temporary fashion. So one of the idea is, okay, suppose I'm asking a question that says that who won F1 race? So let's say this is the question. See, if I want to generate the answer from my LLM, it's not free. It's going to charge us money. Okay. Now, this is the question from the user one. Now, let's say I have the user two. Now, the user two also has the same question. Now, if the user two asks the same question for me that says that who won F1 race, if I call the LLM, even for fulfilling the same query, it's another cost for me. So to avoid repetitive usage of LLM, I'm talking about generative AI, but that's a principle everywhere. To avoid the repetitive calls to the LLM, we'll be storing these data in a temporary database that's called as a cache database. So if I have the question and the answer ready with me, instead of calling the LLM, I'll fetch from this fast access database, and I'll just go ahead and generate the response from this cache memory. So that is the overall idea about this cache. It's a fast access storage layer. Okay. Like this applies everywhere. This applies for your Google search. And let's say it applies in Netflix, everywhere. So it applies everywhere. Let's say if you have recently watched a video, your recently watched video will load faster in Netflix compared to the new video that you're trying to search. So that's the overall idea about this cache memory. Okay. So we have various types of caches. We have the memory cache, database cache. And let's say when we are working with LLM, we have LLM cache, where when I say LLM cache, which is specific to a generative AI, it will store the input and the output from the LLM. So that's what we'll be having. So this will help us to save tokens. That means minimize the cost. And more importantly, it will speed up the response time. So that's the overall idea about this LLM caching. Okay. Any other questions, team? Okay. So thank you so much, guys, for joining in. It was wonderful to interact with each and every one of you. So thank you again for taking your time and joining with me today. And if you're not part of our WhatsApp community, let me just share the link. Just be part of our WhatsApp community so that you can get the updates about our upcoming session whenever we conduct. So I want to ensure that you get the best out of the learning sessions that we are conducting. Let me share you the link in the chat window. If you're not part of our WhatsApp community, just uh, reach out over here, team. Okay. So thank you again. And I look forward to seeing you next time, guys. It was wonderful talking to you. Okay. All right, guys. Okay, there are a few more questions that I see. How to run QA on Agentic AI projects? Uh, can you please add more information this one? I can definitely answer it. And not only loading cache, if considered status like previous chunk watched, how? So, okay. So here, when I talk about LLM or LLM cache, I would only say it is specific to the cache memory. It is specific to the LLM, Saravana. Okay, so previous chunk watched, I'm not sure about the chunk watched because the Netflix example that I gave, it's just for our understanding purpose, Saravana. Okay, so Rahul, okay, you can reach out to the support team, Rahul. I'm just sharing you the number. You can reach out to them. They can help you. Reach out to them on the WhatsApp. I've just pinged you the number. Okay, there was one more question, AK. The question was N8N. So what is N8N? That's a good question. So let's take a look at it. Okay. So N8N, it's a tool that we have got. Okay. What it says, it's a automation tool which combines the AI capabilities. Like think of it as an automation tool. Okay. Like there are various business application tools that we have got, guys. We have something called as Pably. I mean, that's what I've been using. We have Zapier. I mean, we have, let's say, I'll list down the ones that I've used personally. Okay, Zoho Flow, or like this, we also have N18. See, the thing is, when we consider these tools, I'll be using these tools to build the automation around it. Now, there are various automations that I want to create. I'll give you a very simple example. Let's say, I'll give you an example from the context of the website that we are running. Let's say you would, if anyone registers in our platform. Okay. I'll give you a very simple idea about what exactly are these workflows. Okay. It applies everywhere. I'm going to take you through one example. I don't have the N18, but I can definitely take you through this. It is basically helpful for us to create the custom workflow. It has got the integration with the tools. Let's assume that whoever have created an, let's say, registered for the link that I have shared earlier. So by default, you might have received an email from the Zoom that says that your registration is confirmed. And you can actually do that as well. I'll show like the link, what I'm actually referring to. So basically, like the workflow that I've created over here is if someone registers on one application, let's say product one, okay, if some action has been performed, I have to trigger another action. This should trigger another action, which is on my product two. So if someone registers on my website, it should be triggering a registration on my Zoom platform. So to build these kind of automation, okay, we make use of the tools such as N8N, Pably, Zapier, and we can mention about, okay, what information that I have to fetch from one product to the another product. And like those are the few things, those are the core aspects that we would be having. Okay. Now the reason this N8N is famous because now it's an open source platform or it's an open source workflow automation tool. Like when I say Zapier and Pably, they're all paid platform. Now, when I say N8N, it's an open source automation tool. So you can connect your apps, APIs, everything together. It provides some drag and drop interface. So it can also help you to run the custom code as well. So that's the core idea about this N8N tool. Okay. You can actually, like, to give you an idea, since it supports the custom code execution, you can use this N8N to uh, like call the line graph that you have got from the N8N and generate the response and build the rack system. Like you can actually build the AI-based or a kind of system using these tools. That's the overall idea about this N8N. Okay. Two more use cases, medium level complexity, high level complexity. Okay. So before that, can we create vector DB ourselves? Uh, like when you say create, I would say it's difficult because the reason is you're trying to thinking about building a product which is at the top class, which has to work at the production level. So that means I would say it's not like it's not doable, but it's about you should be having a capability to build it vector database. So one way, if you want to just if you're just creating, maybe you can make use of the vector database such as FISS. Instead of creating it as a service, you can just store your vector data in the RAM. That's what you can do it. but you require that database was like a product, that something that you need to create. All right, guys, I think uh, I've answered all the questions. Okay, few. Okay, so thank you again for joining in with us, guys. It was wonderful to interact with each and every one of you. So I look forward to seeing you next time. So do keep do reach out to our do ensure that be part of a WhatsApp group. And if you have got any questions, just reach out to the support team. They can assist you, and follow us on our YouTube and LinkedIn. Just stay in touch, and you can get the free updates about the same. Okay, let me just share the link. So I'm just sharing everyone with the YouTube link. Just subscribe and stay in touch. And I look forward to helping you next time in your learning journey, everyone. Take care.